Okay, so we're going to start chapter 7, point 1 with parabolas. Here are your learning goals below. Make sure you have your foldable that I gave you on last class. The geometric definition of a parabola. So a parabola is a set of points in the plane that are equidistant from a fixed point, which is called the focus, and a fixed line, which is called the directrix. So we're going to talk a lot about the focus, the directrix, and just how we're going to form a parabola. Notice the image that's here. The directrix is simply just a line that is not going to be moved. It's just a fixed line. Notice that your focus is going to be a point away from your parabola, and then it kind of helps you to count out exactly how far your parabola should move from. And your vertex is always going to be where your parabola actually meets. So this is where your foldable comes into place. So the first part we're going to talk about is a parabola with a vertical axis. That means that with that axis is going to go up and down. So the parabola of an equation, recognize this equation is very important. X squared equals 4py is a parabola with the following properties. These properties are very important as well. The vertex is always going to be at 0, 0. The focus is always going to be at 0, comma p, so whatever p is going to become. And then the directrix is going to be y equals negative p. The parabola opens upward if p is greater than 0. It opens downward if p is less than 0. So just notice your graphs and what takes place here, whether they open up or down. Also notice exactly where your focus is and also where your directrix is. The next one we're going to look at is the parabola with a horizontal axis. So that just means it's going straight up and it's going left to right. So the parabola of the equation y squared equals 4px, notice its placement. If it's horizontal, it deals with y squared. If it's vertical, it deals with x squared. This one, y squared equals 4px, is a parabola with the following properties. The vertex is always going to be at 0, 0. However, the focus is going to be switched up where it's p comma 0, and the directrix is going to be x equals negative p. We also look at the direction of the graph. So the parabola opens to the right if p is greater than 0, and it opens to the left if p is less than 0. I gave you these foldables for you all to put in your notebook. I would encourage you to learn these rules because they're very important to be able to identify whether it's a horizontal axis or if it's a vertical axis based on the equation given. Okay, so here's our first example. It says find the focus, the directrix, and the local diameter of the parabola, then sketch a graph of the parabola and its directrix. So first here I want to look at how I start off with x squared equals negative 4y. So this parabola is either going to face downward or it's going to face upward based on the fact that we start with x squared. So I'm also going to list out what the formula says. It says x squared equals 4py. So at this moment, I know that I am looking to kind of substitute for x squared. So x squared is now going to become 4py equals negative 4y. My goal is here to solve for p first. So if I'm solving for p, I'm going to go ahead and divide both sides by 4 and y. Those cancel, and I'm left with p on the left side, and p equals negative 1. So this is now my p-value. Now I can kind of begin to list out what they're asking me for. They're asking me for my focus, which I know my focus is going to have to be 0, comma p. So that means that my focus is going to be 0, comma negative 1. Then I also need to look for my second part, which is the directrix, which for this one I know is going to be y equals negative p. So that means that looking at this, I get y equals 1 because p is already negative. And the last part I want to look at is how do I find my focal diameter? This is really just trying to figure out how much do I have to count out from each part of my vertex to form out how far this graph will actually go. So in order to find your focal diameter, you have to look at the absolute value of whatever 4 p is. Well, we know that p is -1, so I have 4 times -1, which equals the absolute value of -4. The absolute value of -4 is +4. So that means my focal diameter is +4. So I kind of have everything that I need in order to graph this. First thing I'm going to go ahead and graph is my directrix. I'm going to do that in green. So that value is at 1. So at 1, well, I thought it was going to be green. Sorry. It will remain black. So that's my directrix. And then I'm going to plot the focus point, which is going to be at -1. Here's my focus. And then remember that your parabola is always going to start at the origin of 0, 0 for its vertex. But when I look at the local diameter from my focus, half of my local diameter is going to be 2, so I'm going to count out 1, 2. That should be a point, and 1, 2. So the distance between this is a total of 4, which is my local diameter. These 2 points that we just found are our radius. So from the origin all the way down, passing through those points, is exactly what my graph would look like based on the equation given. So we can say that our graph actually is going to point, or sorry, it's going to point downward. So that's our direction. Let's look at example 2. It says find the focus, directrix, and local diameter of the parabola, then sketch the graph of the parabola and its directrix. Well, let's look here. We have y squared equals 12x. So that tells me that I'm either going to have a graph that goes like this, or I'm going to have a graph that goes like this. So when I'm looking here, I'm going to go ahead and write my formula that says y squared equals 4px. I'm going to go ahead and substitute 4px in for y squared because I'm going to look for p. So I'm going to have 4px equals 12x. Next step is to solve for p, so divide by 4x on both sides. Those cancel on the left, and I get p equals 3. That tells me that my focus is going to be 3, 0. Remember, this stems from p, 0. And then my directrix is going to look at just being x equals -3. Remember, that still stems from x equals -p, and our p-value is positive. The last thing I want to look at is my focal diameter, which is simply trying to figure out the absolute value of 4p. So remember, our p is +3, so the absolute value of 4 times 3, which is the absolute value of 12, which is 12. I'm going to go ahead and plot everything that I know. My directrix, go ahead and start with that first at -3. So remember, that's on our x-axis, 1, 2, 3. Begin to go ahead and draw my line there. Then I'm going to go ahead and graph and plot my focal point, which is +3. So that's my focus. Then I can also look at my focal diameter. Remember, it's always going to start here at the origin. Well, half of 12 is going to be 6. So 1, 2, 3, 4, 5, 6. And up 6, 1, 2, 3, 4, 5, 6. So this entire length should be a total of 12. Half of that would be 6. So from the origin, pass through those points, and that is my graph, meaning that my graph opened to the right. All right, example 3. find the focus, directrix, local diameter of the parabola, and then sketch the graph of the parabola and its directrix. Let's go ahead and try this one. Notice how it's set up as x equals -1 over 8 y squared. The goal is to always have your variable squared by itself. So I'm going to go ahead and multiply both sides by -8. So I can cancel these. Those will cancel, and I'll get y squared equals -8x. So now at this point, I know that my graph should either open to that side or to this side. And I also know that my equation is going to read y squared equals 4px. So go ahead and substitute this. So 4px equals -8x. Divide by 4x on both sides. Those cancel, and I get p equals -2. So again, you can go ahead and figure out what everything is. Your focus is going to be -2, 0. Your directrix is going to be x equals 2. And your focal diameter is going to be 8. Skipping through some steps here. So that means when I graph this, I'm going to graph over 2 and plot my line. Remember, it always starts at the origin when trying to graph it. And then my focus is going to be at -2. And my local diameter is 8, so I need to count out 4. From here, 1, 2, 3, 4. And from your focus, 1, 2, 3, 4. Notice how every time I'm counting out from my focus and not the origin. So there's the graph of your image as well. Example 4, find an equation for the parabola that has its vertex at the origin and satisfies the given conditions. So looking at your focus to be -2 and 0, ultimately this is set up as p and 0. Think about your equation that it matches up with. Does it match up with the horizontal axis, or does it match up with the vertical axis? So when looking at this, it matches up with the horizontal axis. So that tells me that I'm going to use the equation y squared equals 4px. Well, if I know p is -2, I can kind of work my way backwards to figure out the equation. So I'll get y squared equals 4 times -2x. So I get y squared equals 8x. Sorry, -8x. And this is my equation. Part B, when I look at this, I know that this is going to be 0, p. So I know that this is going to be a vertical axis. Same thing, except I'm going to use the equation x squared equals 4py. Substitute your p, so you have x squared equals 4 times -5 times y. So you get x squared equals -20y. And that's your equation. Last example says find an equation for the parabola that has its vertex at the origin and satisfies the given conditions. So this time we're giving the directrix where it's y equals 6. For the first one, remember y equals -p here. So we can ultimately say that p for our value is -6. I can set up my equation here that says x squared, because it's y equals 6, I get x squared equals 4py. Substitute p, I get x squared equals 4 times -6 times y. So I get x squared equals -24y. And there's your equation. Let's look at the next one. It says x equals, we know it's -p, but we already know we have a -4 here. That means that p is going to equal +4. We're going to use the equation that says y squared equals 4px. Go ahead and substitute 4 into the equation, and you get y squared equals 16x, and this is your equation. If you have any questions, ask me on Monday. Have a great weekend, guys. Work on your homework.